From 600 miles above sea level, the Earth below seems frozen in time. But in these still images, Karen Seto perceives a world in motion. She can see the urban borders expanding, croplands fading, the density of butterflies and vegetation shifting. From space, Seto can see humanity's footprint widening, changing the face of planet Earth.
I'm an epeiist, and I'm also a water skier, and I fence all year round. I got into it because my son's a fencer. I was taking him to tournaments, and I thought, wow, that looks like a lot of fun. A weapon, you can stab people. It's fantastic. It's very aerobic. It's very intellectual. People compare it to chess. It's a lot like chess. If you do this, they do that.
As an urbanization and land change researcher at Yale, cause and effect is Seto's domain. She puzzles out the nuanced ways nature responds when our cities expand. Unlike fencing, Seto's science plays out on continental scales. So in the 1990s, a core challenge was finding a data-gathering perspective that preserved the fine details without losing the big picture.
This is in 1992. It's my first year in graduate school at Boston University, and I have to emphasize that this is before Google Earth. The internet was just getting going. And at Boston University, I was in the geography department. They had a very strong remote sensing program. And I saw this satellite image of Hong Kong. And I just remember this visceral, I still feel it now, this visceral feeling of, that's where I was born. And you could see across the river how different the land was in China, that you could see the difference between Hong Kong and China from a satellite image. That was incredible. It literally opened up my eyes to a whole new way of seeing.
Seto's perspective would be low Earth orbit, and in the 90s, NASA's satellite images were neither high-res nor cheap.
So you had to pay. The satellite images back in the 90s were $4,500 each. So we didn't use very many because they were very expensive. We would download the images, and then you'd have to write code for everything to bring up the image, to do any kind of transformation.
Unfazed, Seto turned the space-based lenses on rapidly urbanizing China and began to take notes. As the years passed, she saw mountains carved low, rivers reshaped, skyscrapers rise from pasture land. But there was one problem. From space, the fine details were invisible. But Seto understood that satellites had many ways of sensing the world below.
In infrared, Seto could tell wet irrigated soils from drained surfaces by their heat signatures. Because photosynthesis absorbs red wavelengths, she could see healthy vegetation decline as buildings went up. Variegated greens like these corresponded to the changing richness of birds and butterflies. Seto harnessed the senses of the electromagnetic spectrum, and suddenly the frozen world as seen from above came alive.
When there's a new urban development, you're going to need other materials like copper, like steel, like sand. Those are coming from faraway places.
Building cities makes mines from mountains. It ravages distant forests, releasing carbon trapped in the soil. And this underlines a key takeaway from Seto's work. The effects of urbanization aren't local. They drastically shape land hundreds of miles away. Seto can actually forecast it.
Once you build a road, it's very difficult to change those patterns. The way in which we build our built environment at the very beginning has this long legacy that lasts actually hundreds of years.
And this can directly lock in a hard-to-break cycle of increased carbon emissions.
Where people live versus where they work, that co-location is one of the biggest factors in urban emissions.
Seto's work doesn't ask us to stop building. It asks us to finally look into the invisible costs. If we want thriving cities and a thriving planet, we have to be smarter about growth, more honest about trade-offs, and more courageous about what we change. The map we draw today is the world the next generation will inherit.